A fan curve should be measured, not assumed. One reading cannot describe a fan across its operating range. A useful aerodynamic test links airflow, fan pressure, input power, rotational speed, and air density at a series of stable operating points. This is a real longwall test chamber. The footage proves that a physical fan, chamber, and measurement system exist. It does not, by itself, prove AMCA certification or validate a performance claim for an unidentified product. Keep that boundary clear. First, define the test boundary, the test fan and its appurtenances, inlet and outlet conditions, transitions, settling sections, measurement planes, nozzle bank, and the device used to control the operating point. A curve is meaningful only when the configuration behind it is documented. AMCA 210 and Publication 211 do different jobs. The current ANSI/AMCA 210-25 standard establishes uniform laboratory methods for determining aerodynamic performance, including airflow, pressure, power consumption, air density, rotational speed, and efficiency. Publication 211-26 is a certified ratings program manual covering rating and publication procedures. A test method is not the same thing as certification. One common airflow method uses a flow nozzle or nozzle bank. The nozzle geometry is known. Differential pressure is measured across it, and airflow is calculated using the relevant area, air density, and coefficient. Multiple nozzles extend the measurable range, but the active combination and test basis must be recorded. Pressure deserves equal discipline. Static taps, averaged connections, straighteners, or other settling means and leakage control help create a flow field that can be measured consistently. A pressure number without tap locations and a test setup is incomplete evidence. Each operating point needs a complete instrument chain, airflow, fan pressure, electrical or shaft input is applicable, rotational speed, temperature, barometric pressure, and humidity when required for the air state calculation. Calibration status and stable readings matter as much as the display resolution. Next, vary the system resistance. Move from free delivery toward higher pressure, wait for stability, and record multiple points. The resulting curve shows how pressure, airflow, power, and efficiency change together. It also exposes unstable or unusable regions that a single catalog point can hide. Raw readings are not the final rating. Record the exact setup, fan configuration, units, density, speed, calibration status, and calculation basis. Reduce every point to the declared basis, preserve raw data, and state the tolerances or uncertainty used when the curve is fitted and published. This real longwall data screen shows a sequence of recorded test points. It is valuable evidence of workflow, but a buyer still needs the product identity, setup drawing, raw readings, and calculation basis before quoting any number. We do not infer an unseen certification result from the screen. Keep 4 statements separate: tested to a method, tested in an accredited laboratory, ratings certified under a program, and a product line currently listed. They may be related, but they are not interchangeable. Certification claims require the program rules, license scope, and current listing, not just a familiar-looking chamber. For a defensible fan selection, ask for the current standard edition, setup drawing, tested fan and appurtenances, instrument and calibration records, airstate data, raw pressure points, airflow calculation, power and RPM, reduction basis, complete curves and tolerances, and the current certified listing if certification is claimed.